Let's try another example of the extended Euclidean algorithm. So given m equals 213 and n equals 182, we're going to find the GCD and also solutions to the equation. So first step, find the GCD. So we've got 213, 182 is going to go in there one time, so 1 times 182. Then take 213 minus 182, we get 31. Bring down the 182. So we need to see how many times does 31 going into 182. So we've got 182, so 1 divided by 31. You can see that it goes in there 5 times, and so our quotient is going to be 5 times 31. To find our remainder, take 182 minus 5 times 31. So this leaves us with a remainder of 27. Bring down the 31. 27 is going to only go in one time with a remainder of 4. Bring down the 27. 4 can go in there 6 times. 6 times 4 is 24 with a remainder of 3. Bring down the 4. 3 goes in one time with a remainder of 1. Bring down the 3. 1 goes into 3 times, so 3 times 1 plus 0. So this is another example of two numbers that are relatively prime. So the GCD of 213 and 182 is equal to 1. So we're looking at this value to find our GCD. So the second part, the extended part, is that we now want to solve 213x plus 182y equals our GCD of 1. So we start out with this line of our Euclidean algorithm that has the plus 1 and rewrite it with 1 on one side by itself. So 1 is equal to 4 minus 1 times 3. Now I'm going to replace this 3 using the next line up. So solving this equation for 3, 3 is equal to 27 minus 6 times 4. And then go ahead and simplify this. We have 4 minus 1 times 27 minus a negative is plus 6 times 4. So 1 4 plus 6 times 4, now we have 7 4s minus 1 times 27. Now in my next line I have the plus 4, so I'm going to replace this 4. Using this line I can replace the 4 with 31 minus 1 times 27. So keep the 7 out in front, replace 4 with 31 minus 1 times 27 minus 1 times 27. So distributing, we have 7 times 31. We have minus 7 27s minus another 27, so we have minus 8 27s altogether. So now I'm going to look at this 27, and notice in this line we have a 27. So I'm going to replace the 27 with 182 minus 5 times 31. Distributing, we have 7 31s. Negative 8 times negative 5 is plus 40 31s. So 7 plus 40, we have 47 31s minus 8 182s. So backing up one more time, we're going to use this line with the plus 31 to replace this 31. So 31, we can replace that with 213 minus 1 times 182 minus 8 times 182. So we have our 47 213s minus 47 182s minus another 8. So minus 47 and minus 8, we have minus 55 times 182. So this is showing us that our value for x, the number multiplied times 213, will be 47. Our value for y will be negative 55. So we found values for x and y, as well as finding values for our GCD of 213 and 182. So before going on to the next part of the video, pause the video and try the next example at the top of page 4 on your own. So see if you can find the GCD of 555 and 2146, and then use the GCD to then solve the equation. So even though the larger number is written second this time, go ahead and just flip those around. Write the 2146 first. Find out how many times 555 divides in there. So take a moment, try that on your own. Let's see how you did. So starting out with 2146, so 2146, we need to divide that by 555. So the quotient is going to be 3. It divides in there 3 whole times, so we'll have 3 times 555. And then we need to find the remainder. So we need to take 2146 and subtract 3 times 555. So this leaves us with a remainder of 481. Bringing down our 555, 481 goes in 1 time. 555 minus 481 leaves a remainder of 74. Bring down the 481. Using your calculator, see how many times 74 goes into 481. The whole number will be 6, so 6 times 74. 481 minus 6 times 74 leaves a remainder of 37. Bringing down the 74, we find that 37 goes in an even 2 times. So 2 times 37 plus 0 is equal to 74. This tells us that our GCD for 555 and 2146 is equal to 37. So now we want to work on how we can solve 555x plus 2146y equal to 37. So we want to start with that 37 on one side by itself. So we'll start with this line of our Euclidean algorithm. So 37 is equal to 481 minus 6 times 74. And now replace this 74 using the next line above from our Euclidean algorithm. So we have 481 minus 6 times, in place of the 74, we'll have 555 minus 1 times 481. So 481, a negative 6 times a negative 1, it's plus 6 more 481. So 1 plus 6, now we have 7 times 481 minus 6 times 555. So now I'm going to replace this 481 using the first line from my Euclidean algorithm. So 2146 minus 3 times 555 minus 6 times 555. So combining like terms, we've got 7 times 2146 minus 21 and minus 6. Altogether we have minus 27 times 555. So just be careful on the order here depending on how you wrote the original equation. I have 555 times x, so the number that gets multiplied times 555 is the negative 27. For our y, the number multiplied by the 2146 is a positive 7. So x is negative 27, y is 7, and these are solutions to the equation 555x plus 2146y equal to 37. So along the same idea, let's look at one other type of problem that we can solve using what we've seen with the extended Euclidean algorithm. So here we're given an equation and we're asked if it's possible to solve this equation, and if we can, to find the x and y that satisfy this given equation. The equations that we've been solving so far, the number on the right-hand side of the equal sign has always been the greatest common divisor. So the first step in working on a problem like this is to find the GCD. So in this case for 216 and 153. So let's start with that. So 216 is 1 times 153. Our remainder then is 63. Bringing down our 153. So 153 divided by 63, it goes in there 2 whole times. 153 minus 2 times 63 leaves a remainder of 27. Bringing down the 63, 27 goes in there 2 whole times. 63 minus 2 times 27 leaves a remainder of 9. And 27 is 3 times 9 with a remainder of 0. So our GCD for 216 and 153 is equal to 9. We're looking at this value for our GCD. So now the thing that we want to look at is we want to know, does 171 divide evenly by 9? Is it a multiple of 9? 171 divided by 9 is 19. So this tells us that our GCD divides 171. What this means is that if we can find a solution to 216x plus 153y equals the GCD, we'll be able to multiply by 19 to find solutions to this new equation. So step 3, let's find solutions to 216x plus 153y equals 9, our GCD. So starting with 9, we're working backwards starting at this step. 9 equals 63 minus 2 times 27. Now replace the 27 using the step above. So replacing 27 with 153 minus 2 times 63. Combining like terms, we have 63 negative times negative plus 4 times 63. So we have 5 times 63 minus 2 times 153. Last, replace the 63 using the next line up. So we've got 5 times 216 minus 1 times 153 minus 2 times 153. So we've got 5 times 216 minus 5 and minus 2. We have minus 7 times 153. So we have x equals 5 and y equals negative 7. So last, let's extend this now to think about a solution with 171 on the other side. So I'm going to take my 216x plus 153y equals 9. We said 171 divided by 9 was 19, so I'm going to multiply everything by 19. So I have 216 times 19x, and 153 times 19y equals 171. So our new solutions, the x and y in our original, so these are kind of like x1 and y1 that we were working with here. Our original x and y that we wanted will be 19 times x. So 19 times 5 is 95. Here for y we had negative 7. Negative 7 times 19 is negative 133. So we found solutions to an equation that were set equal to our GCD using the extended Euclidean algorithm. Once we had solutions to that, because 171 was a multiple of the GCD 9, we could take that and use it to find solutions to the original equation we were given. So along that same idea, if we think about this last problem, we can see we run into a problem in that 2277 is not divisible by the GCD. So starting out with 1054, we'll use positive 833. We can extend our results to this negative 833. It's 1 times 833 plus 221. So you can work these next steps out on your own. Bringing down the 833, you'll get 3 times 221 plus 170. Bringing down the 221, you'll have 1 times 170 plus 51. 170 is 3 times 51 plus 17. And last 51 is 3 times 17 plus 0. So the GCD is 17. Well, when we look at 2277 divided by 17, comes out as like 133.941. So that means 17 doesn't divide in evenly, or 2277 is not a multiple of 17. So since 2277 is not divisible by the GCD of 17, no solution is possible for that equation, 1054x minus 833y equals 2277.